Okay, welcome everybody. We're super excited for this Sawtooth webinar. Welcome from all over the world. Good morning, good afternoon, good evening, and welcome to another Sawtooth webinar. This actually, just so you know, is the most popular webinar we've ever put on. Most registrations we've ever seen in the history of Sawtooth software. So we're super excited for that. And I know there's a lot of you that are probably new to Sawtooth, so welcome to you as well. So welcome to the webinar, Synthetic Survey Data, It's Not Data, from Chris Chapman, the Quantitative User Experience Association founder and organizer. And we'll talk a little bit more about Quant UX here in a second. Just some webinar details before we get started here. We're here in Zoom. There's a Q&A section that you can use at the bottom of Zoom. Don't use the chat feature. We, for the most part, we're going to hold all questions till the end. Chris has been very generous to say that he is willing to go over the 1 hour allotment, right? So if we have lots of questions, we will keep talking past the top of the hour and go into the next hour. You're welcome to leave at that point, of course. But just so you know, we anticipate lots of questions, and Chris is gracious to stick around for those. A few announcements before we get started here. Some upcoming Sawtooth events. So next month, March 18th through 20th, out in San Francisco, California, we will be having a Sawtooth workshop presented by Brian Orm, and he will be talking about MaxDiff and conjoint analysis. And this is also our first chance that you have to receive a MaxDiff certification from Sawtooth. This is a new thing that we are rolling out, and you'll be able to get certified in MaxDiff. Also, March 26th, we'll have another Sawtooth webinar. We have about one a month, and the next one's entitled Pricing Research Tools You Must Know from Sawtooth CEO Brian Orm. The big event that we're excited to announce is that May 6th through 8th out in Berlin, Germany, we'll have our Sawtooth Research Conference. If you've not been, highly encourage you to check it out. It's one of the best conferences in this area in the world. And we have so many great presentations. And also on our website, we have an archive of all our past presentations. Really highly recommend that you check that out. And you can do that by going to sawtooth.com/events. So you can see all of our events. Also want to give a plug for Quant UX Con. This is this conference that Chris Chapman has organized with a committee, and it is exceptional, very low cost, and coming up in November, and you can learn more about it at quantuxcon.org. Okay, a little bit more about the SRC Sawtooth Research Conference. Just wanted to let you know that this topic, of course, of synthetic data is very popular, and there'll be additional presentations on synthetic data coming up at our conference. Just read through these, right? Can synthetic respondents replace the real thing by Ipsos UK? And they will actually be giving a follow-up webinar on June 18th. Another presentation, Can Synthetic Data Alleviate Low Feasibility for Advanced Modeling by KSNR? And Can LLMs Beat Traditional Imputation Methods at Imputing Missing Data by NIQ? And there's more on this subject, along with many other items and presentations at the SRC. Early bird registration ends March 2nd, so get in before that, save some money. And if you can't make it out to Berlin, there's a virtual access option that you can explore. Okay, one last item here. If you're not familiar with Sawtooth, we highly encourage you to check us out. We are best known for being the best in the world at conjoint analysis and MaxDiff. But what I want to let you know is that you can do much more with Sawtooth. You can do all your surveys with us. We have a powerful survey platform. It's easy to use. It's modern. We have incredible support. We believe the best in the industry. And you can try us out for free at discover.sawtooth.com. Okay. Without further ado, I would like to introduce Chris Chapman. Chris, you can go ahead and turn on your camera, the big reveal. Here's Chris. Chris is, first of all, let me just say, super nice gentleman to work with. We've known him for years. He's super nice and smart. And if this is your first chance listening to him, you're going to be in for a treat. Chris has worked in marketing analytics for 24 years, has tons of experience at Google, Microsoft, and Amazon. And I think I can say, Chris, you've retired now. And well, maybe not. You can clarify that. And he's now founder and president of Quantitative User Experience Association. He can speak on that. And Chris is also the author of 3 books, R for Marketing Research and Analytics, Python for Marketing Research and Analytics, and the book Quantitative User Experience Research. So, Chris, with all that, turn on your mic and share your screen and let's hear.
Oh, thank you so much, Justin. I'm delighted to be here. Thank you for inviting me, and thank you to all the folks in the audience too. And I will share my slides.
While you're doing that real quick, just to let everybody know, we're also joined by Keith Sean, who's the head of Sawtooth Consulting, and Dean Tyndall, who is the managing director of our European office. So he's here as well.
Yeah, well, thanks everybody. Um, so as Justin mentioned, I'm semi-retired now. I run the Quant UX Association and also some other things, and retired from industry. And one of the things in the talk today is I take a fairly hard line against synthetic survey data for reasons we'll explain. And I'm fortunate enough to be able to do that after all these years in industry. It's I see some of my role now as as providing the truth as I see it from a research perspective. So I hope to do that today. And first, I'll start with the definition of what is synthetic survey data. Sometimes folks use, synthetic is used in a number of different ways, but what I'm using it to mean today is survey responses that are obtained from a large language model, AI system, that are used to supplement or as an alternative to other data that might be obtained from people. For example, use an AI system to take our survey, and then we analyze its responses on their own or in conjunction with human data. And I think most of us in this talk are familiar with, suppliers and who are pushing this as a new business, for either primary data or augmentation of data. So I'm going to cover, 4 main things today. One is that I will argue that synthetic data is never good enough for any particular problem, and that we can never know a priori that it's good enough. Secondly, that the fundamental concepts of statistics do not apply when we're talking about synthetic data. And then beyond that, I also believe that many discussions of synthetic data and of the statistics of it misunderstand the point of survey. So I'll make an argument for that. And then I'll consider some counter arguments. And what I will say is you don't have to agree with all 3 of these points. I think any one of them is enough to kind of knock synthetic data out of significant consideration. But you could disagree on any one of them and still agree with the others. So, I'll make that case. All right. So there are 2 paths that we might have to find out what people think. So one we're all familiar with is we identify our business question and we ask people, how much do you like candidate X in a political race? Would you consider buying our product? Whatever. We ask people. A second path is to do something like the following. So we compile billions of documents, we build an AI model, we train it, we build a query engine, we create digital twins that we're going to use to prompt it, and so forth. That's a much more complex path to do that. And I believe there's no scientific or theoretical reason to expect that path will work. So it could fail because of biased data, training, the algorithms, its coverage of the corpus of knowledge, problems with our twins, etc. So there's no a priori reason to think it will work. Yet oftentimes people say, well, let's try it and see whether it works. And with an infinity of possible questions that we might have, I will argue there's no way to prove in advance that this process, path two, will generalize to anything that we care about. So without that a priori expectation that it will generalize, we're left with kind of three options here. One is we could use it for trivial things. Let's prompt it, and if we get an answer, fine. If we don't, fine. And another option three is to just believe that it works. So to ignore any investigation and just accept it. Neither one of those is particularly appealing, for actual research projects. They're non-trivial, and we shouldn't just believe that something works without evidence. So that puts us in the camp of proving that it works for every project, or maybe proving that it works in advance for a whole large set of potential projects. And that's the path that I'm going to talk most about today. To prove that it works for a particular project requires data. And that leaves us with the question of, well, why not just use that data? And some folks go down the path of data augmentation, and I'll talk briefly about that near the end. Now, I often hear rebuttal here, but wait, it does work. And I would add a sanity check to this. First of all, let's suppose I can predict people's real-world preferences using synthetic data so that I can ask it, what people think about, anything, insert random question like we might ask on a survey, and let's imagine that I can get back, better than random data for that. I would use it to predict preferences for stock market trades, and then I would go invest money in that. So if I believed that it could do this, I would make those investments. But as far as I know, no one is doing that successfully. And the vendors of these LLM systems themselves are selling their data rather than holding it as a proprietary model and investing on it. So I have this sanity check inference of like, I don't think the vendors themselves believe that it can generally predict preferences. So I have that kind of in the back of my head. And then I often hear this, wait, it really does work. A vendor showed me a study where they showed they did this thing and it worked. And I'm not going to take on any vendors by name here. That's not my job today. And I, respect many vendors very highly. But what I will say is that I bet when they did their study that they did what I'm going to describe in the next section. And that is that they evaluated it using statistics. And I will argue that it cannot be evaluated using statistics. So what's the typical process that goes through to show that LLMs will, quotes, work to generate human-like responses to survey? So a typical process, there are variations on this, but I believe this is most common, is that they start with some degree of human data. So it may be, data from a census, it may be data from a previous study, data they collected generically, it may be a small sample in their domain, but they start with some, sample or statistical representation of people. Then they create digital twins. We'll see an example of this where they use, what they know about people from the prior study to create a prompt template. And then they use the LLM to, quotes, take the survey for each person in those digital twins. Or, there are variations on this. They get back the answers from the LLM and compare those to human data. And so this process is very typical in academic and supplier papers. And I think we can ask several questions about it. One is it cherry picked? How many times did they do this? Do we know? Are they just showing a kind of N of one success case? If it works in their domain, how do we know it will generalize to our domain? Another question is whether the template itself, so these things depend crucially on the exact details of the prompts. Is that really validated? How can we know that? Another is that the process of an LLM, quotes, taking a survey is a very different process than a human taking a survey. And I'll say more about that in section 3 of the talk. And then number 4, which is in this section, is that doing the statistics to compare the LLM results to human data, I believe it doesn't work, and I'll explain why. Right. So an example LLM prompt would be the following. And I took this from an excellent study that I'll reference a few times from G. Elliott Morris and the Verisight data team called Your Polls on ChatGPT. I've got a link here and it's in the final references slide that I'll show. And their prompt, I think, is fairly typical and it looks like this. I'm not going to read it, but it tells the LLM, act like the following persona, and it's going to fill in some persona details and then answer the following question. And if they get the persona details by looking at, the census data or prior or concurrent survey for a human, and then they fill it in with the data of that human. You are, 52-year-old, woman of, Latino race, education level is college graduate, etc. They fill this in as part of this prompt to the LLM. And then they give it a question such as, in a specific study, they asked, do you approve or disapprove of the way Donald Trump is handling his job as president? And then they have a response scale that would be a typical Likert type response scale that they fill in. So Morris and Verisight did this, and they subjected this to 6 different AI models, and which are shown here. And this chart's kind of noisy, but the actual human responses, they did a human sample of, I believe it was 1,500 people. I don't remember the details. And so the actual human level responses are in green. The responses they got from these 6 LLM models are in orange on this chart. And so then they compared how often the people and the models across these 6 models agreed. And a couple of interesting things I'd point out. One is that the models were most incorrect on the negative side. So we see in the upper left, for example, humans somewhat disapproved on this question at 11%, but the LLM GPT 4.1 Nano gave that response 60% of the time. So these differences were largest on the negative side, which is interesting because, as marketing researchers, what we know is that these negative direction responses are often the most crucial for our customers and the ones that really, can drive problems with the brand. Also pointing out that these 6 models themselves, these I believe were all OpenAI models. I'm not sure about O4. The models disagreed among themselves often quite dramatically. One would say, 60% strongly disapprove. Another model from the same company says 19% in the lower right, and so forth. I've only highlighted a few of the differences here, but a lot of differences across the models. We also see that their performance was worst generally on the groups that are least represented in the training data. This is no surprise, but when we get to kind of traditionally underrepresented groups in our data, the models were off by the most, which is a contrary point to what many suppliers are claiming, which is that the models can reach these exact people. So it's questions that. I'll point out these data asking about presidential approval in the United States are perhaps the most polled and written about and sampled survey topic in the world. I don't know of a survey topic that's polled more than this in the attitudinal space. And I would say if these models don't perform well in this space, there's no reason we would expect them to perform better in our typical UX and marketing cases where we might have a novel product or a novel topic where there's not prior training data because we have a new brand or feature, and where there's also no prior art on the questions to ask. These kind of political surveys have been studied, for many decades, and they know exactly how to ask the questions. And we often don't know that in the space we're working in. So we should expect less precise data than we would have in this case. I'm going to go back to the statistics story here. So many analysts might take this, and these are using the real Morris data. I've got an appendix here in these slides with R code where you can recreate these charts. The data and the code to do these is right there. So these are the real data from their study. So we can see that the human distribution and the LLM distribution, are not only disagree, but they're shaped differently. And if we look at the net over and under, so the approve versus disapprove kind of gap, very similar to a net promoter score or something, we'll see that it was off in these data by 30 points for this specific model. Um, and so this, is the kind of thing we might look at in comparing LLMs. And then, of course, we could do a statistical test. And this is a chi-square test on their data. And we see that it's, quotes, highly significant here at the p-value that's, the minimum value that R can compute. Again, I've got the code for this. But I want to drill into what this is really saying. So when we do this kind of statistical test and we get a p-value, if I somewhat paraphrase a statistics language, it says something like the following. Assuming that we have random samples, a random sample on the human side, randomly sampling people, and randomly sampling, the LLM, and our null hypothesis is that there's no difference, that they're the same, then we reject that null hypothesis and we conclude that the human and the LLM data distributions are different. So that would be kind of what's going on if we unpack the statistical test of comparing these two data sets. At this point, especially if you're a qualitative researcher, you might have this response, oh no. And if you're a statistical researcher, you might have this response of, oh no, I don't want to talk about null hypothesis statistics testing. Those are valid responses on all sides. And I'm going to drill into, some of this, oh no, kind of response. So first, assuming that these are random samples on the human side and the LLM side, we could ask the question, well, which part is random sampling on the LLM side? It's true we can, quote, sample it many times by prompting it many times, but are those random? What makes them random? Is it the training data, the algorithm, the prompt you're using, the fact we're filling in the prompt with human data, the fact we're telling it to do it many times? It's likely that responses, if we're not prompting it with different data, will be autocorrelated, meaning that they are not random. So, the concepts of random sampling don't apply here. We do not have an enumerated population of potential responses from the LLM that we are randomly choosing. Nothing about it is random. So that's out the window. You might think, well, that's true, but no sample that we have is ever random. So when we sample people, that's not random either. And I'd say that's true. First of all, it doesn't logically imply anything about LLMs. The fact that human sampling has issues doesn't imply that LLM sampling is therefore okay. But it also sets up a main point of section 3. So I'm going to come back to this question of sampling when we get there. And meanwhile, I'm going to go back to the statistics here. So we can believe they're not random samples. And then there's a null hypothesis of no difference. And the question is, why should we assume there's no difference? We know they're coming from different sources. They're queried differently. The survey's presented to them in different formats. A prompt is not the same as taking a survey on, say, a mobile device. They're done at different times. They're based on different sets of information. People and LLMs don't have the same information. They respond using different cognitive mechanisms and different motivations, and they've been shown in many studies to differ. So there's no real reason to expect a priori that they will agree. So this null hypothesis of no difference is presumptively incorrect. Our correct assumption should be, no, they will be different. But unfortunately, statistical null hypothesis testing, if you say, well, we assume they're going to be different, and now we're going to do a null hypothesis test, it's uninterpretable. Or you could even say it's invalid because we expect them to be different a priori. And so then the question is, well, how are they different? Now, when two sets of things have different data generating processes, then it's nonsense to compare them statistically. And I'm going to give a couple of examples of this. So one, if we collect, a kind of qualitative research of people here, and we might take, people are studying and we want to go ask them about their study habits, something like that. it kind of makes sense to compare them. We can take samples of these people, we can find them, we can, maybe approximate a random sample or match it to a census or something, and it makes sense to compare them. But if you want to compare, what this nice gentleman on the right thinks compared to, a golden doodle, I have a golden doodle taking a nap right over here. It doesn't matter. Could ask them both a survey question, but the doodle's not going to make sense to compare it to what the person says. Similarly, if we sample business audiences on the left, makes sense to compare them. If we sample a party versus, a government meeting on the right, they're completely, non-aligned samples. It would make no sense to do a statistical test between them because they're not samples of the same population. For sampling flowers, that makes sense. But if we sample, a shell whose design follows a Fibonacci sequence, try to compare that to, the output of a Fibonacci sequence, it might be interesting. It might even, spur ideas for us, but it really makes no sense to do a statistics test because they're totally different things. Now, moving to the AI space, if we want to do multiple prompts of an AI system on the left and compare them, that makes sense. Comparing their prompts to what people say in a town hall meeting, that probably does not make sense. They're presumptively different. And I will say that these models, as we just saw in the empirical data from Morris et al., if we prompt different models here on the right, we should expect that they will be different. One reason we should expect them to be different is that the companies themselves are releasing them, claiming that they're better or different or superior or faster or cheaper or whatever. So the companies themselves claim that they're different, and we should expect them to be different. And that poses the question, but how would we know that they're different? Back to my starting point. We should assume that these two paths will be presumptively different, asking people versus asking LLM and going through this process. So to recap so far, so we know that humans and these AI systems, have incomparable data generating processes. They just work differently. They have different sampling mechanisms and concepts. Traditional random sampling or match sampling just doesn't apply in the AI space. And our null hypothesis that they should be the same is presumptively false. We should assume that they will be different. There's no reason theoretically to assume that they're similar. That comes from sampling theory about random sampling, that assumption. So therefore, traditional statistical inference testing between human and LLM samples is uninterpretable. So we can do math. We can take the data from people and the data from LLMs, and we can compute the differences. The formulas work, and that is math, but it is not statistical inference because it is not using the correct concepts of sampling and hypothesis testing and comparable data generation processes and all the things that are the underlying statistical concepts that make it possible to interpret the math. So we're left with the math, but we have no inference actually on what it means. So, and I think that's kind of the key point of this talk. If you're going to take something away from it, is that when vendors say we did this sample and it matches this other thing, we cannot interpret what it means. So to drill into that, this difference that we saw in the Morris and VeriCite data between humans on the one hand and LLMs on the other, it shows mathematically that they're different distributions, but we don't know if we repeat that study whether it will generalize to another sample because it is not a sample of an enumerable statistical space. And even if these are fake data that I made up, it's in the R code in the appendix, even if they had looked almost identical, it is also uninterpretable and will not generalize to another sample for the same reason. So either one of these cases, whether it looks vastly different in a study or looks almost exactly the same in a study, it does not generalize because the concepts of statistics do not underlie these comparisons. So if we think about the infinity of surveys, we have something like this. There's an infinite number of things we could ask, and we can ask them in an infinite number of ways, approximately. And we will see studies where LLMs succeed in some cases, and they fail in other cases, and we do not know how those things map to this infinity of surveys. There's no way to characterize what a sample is. So with people, we can, in principle, line up all 8.3 billion, I think it is, people in the world and number them and draw random numbers to do a random sample. In practice, there's some problems. I'll come back to that. But we don't even know how to do that with LLMs. There's no way to line up anything resembling a sample that would let us do statistical inference. So we don't know when they will work or when they will fail. So the space of potential success and failure might look something like this. They succeed. If we think of the space of potential problems out there and it's vast and it's unstructured, we'll see areas where they succeed in green and areas where they fail in white. And we don't know if we move from one pixel here to a neighboring pixel, which is to say, move from one problem where it, quote, succeeded to another problem that is our new sample, our new survey question. We don't know now whether it will succeed or not because this space has no structure that is knowable in advance. Okay. But I think there's another problem that I'm going to go even a layer down from asking that question at all, which is I think much of this enterprise misunderstands the point of surveys. So this is perhaps, I would say, the first two parts of this talk where I lay out that we don't know a priori whether it will work or not, and the concepts of statistics do not apply. Um, you know, I think those are more a matter of looking at statistical science than a matter of opinion. This third part gets a bit more into like my own view of what surveys are doing and how we should think about them. And I'm going to take a brief digression into survey error first, because I think it will help motivate some of this thinking. So we could take something like these results, which come from the Morris and Verisight study, and look at the average error, the mean average error for such data, where we take, folks that don't know, the AI said 10% and humans said 3%, and we take that difference and we take the differences of the other points, we add them up, we divide by 5 points, and we see that on average it was off, this model was off by 22 points, which is shockingly high for polling data, especially an extremely highly polled topic. But you might think, well, we only need directional evidence, right? So we know the AI is not going to be exact, but maybe it's good enough for a business case. And I'd say, well, do you care whether an answer is off by 22 points or not? And you might say, well, no, we only need a direction. So I don't care. It's 50 points, 72 points, 94 points. I don't care if it's 22 points different. I just need to know the direction. And then I think about, well, what if I'm talking with a business stakeholder? And I say, well, our new product that I've tested will interest 1 billion people. But if I'm off by 22 points, the world product, it might be 0. The product that I claim will interest 1 billion might turn out to interest 0 people. Or I will say this product's a terrible idea. We believe it will interest 0 people. But if I'm off by 22 points, that would be 1.8 billion people in the world. All right. So the problem with this is that it's not actionable. Once we start putting realistic bounds on these things and we say our product interests somewhere between 0 and 1.8 billion people, I can say that confidently as a researcher, perhaps, but it's not actionable as a business decision, and it will ultimately kill my credibility as a researcher if I keep bringing back answers like that. And again, I'll remind you, this is on the most polled topic perhaps in the world. Now, if you might say, well, I don't really care about an error of 22 points in a survey, I would say probably your question is insufficiently focused. Or maybe you don't have a need for research, or maybe you'd be better off doing small scale research where you'll have more depth and nuance anyway. So if you're in this camp of like, all I need is a direction, I don't really care about the precision, then I would pose the question, do you really need, statistically based survey research at all? You may be in some different research space. But even all of this and talking about the error, I believe relies on a misleading concept that shows up not only in the AI space, it shows up throughout, research, which is the idea of a latent true score. And I'm going to make an argument that we should concern ourselves less with latent true scores. So there are three truths I propose about survey responses. Number one, respondents take surveys for their own reasons. So they are motivated responses. Those responses, as we know, can differ profoundly based on their circumstance, how we ask them, the wording of our survey items and our scales. We've all seen things where you ask people support one thing, you ask it one way, they do, another way they don't. Also, respondents do not owe us any true response as we conceive true response. Respondents take surveys because they're interested in the topic, or they want to help us, or they want to complain, or they're bored, or they want to earn money, or they are ethically motivated to try to sabotage the research, or whatever. As a researcher, I believe all of those are legitimate. I don't believe these are, quote, bad respondents. These are people who are taking my survey and they are taking it for their own reasons, and that's wonderful. I'm glad they're taking my survey and they're all legitimate. But none of this goes into this concept of a true score. We know that the responses they give us vary tremendously by wording. I'm not going to belabor that point, but I will say the following, that happens due to their circumstances, how they interpret the words, and their motivation for the response. And those three things, the circumstances, the cognitive interpretation of the wordings, and the motivations, are not the same for AI systems and humans. So we should assume that responses will vary between those two, as well as, across different item wordings. Third, this question of whether respondents owe us a true response, whether a respondent's a bad respondent or not. First of all, I would say that if responses are motivated, then it doesn't make sense to consider that there's a true response because their motivations will differ from my motivations. I want people to tell me maybe how much they like my brand, but they may be motivated to take the survey to tell me a problem that they had with customer service. So their situation and motivation are different than mine, and that's fine. And if people take the surveys for lulz, or they want to run survey bot farms or something like that, I don't in principle have a problem with that. People are people. My job is to motivate them to try to take the survey for reasons that align as closely as I can, with the business motivations that I have for asking a question. And that may mean trying to get panels that are not bot farms. That aligns with my motivation, and that's fine. I try to align their responses with my motivation as best I can, but I don't believe that there's some true thing out there that I'm approximating in doing that. So the opposite of a true score on a survey is not a false score. So this idea of a true score that we're somehow sampling when we do a survey, we think of this as being something that lives in people's heads. They have some degree of liking of my brand, and that lives in their head. And I need to write a survey item that's going to go and probe that liking and bring back, as approximate of a truth of that as I can. We can see this as being an unchanging, real value that's out there, plus some error in how we measure it. We believe that it can be, put on a scale in principle, and we believe that it is, a mathematical value that should be exact if we could only exactly reach it, and we can't, so we reach it with error. So this is a classical concept of a true score. But actual responses do not live in people's heads. People do not go around with a liking of a brand. If we think about the fact we can answer or ask an infinite number of survey questions, there is not an infinite number of exact values living in people's heads that we're going to go and measure and prime. Rather, they construct the response of what they want to say about my brand when I ask them. So it's a constructive, interactive effect between me and my survey and them and their situation and all that. And so it becomes expressed, but it's not living out there as an unchangeable value. So it varies with context. It's imperfectly mappable to any scale, and it's fuzzy and flexible. If we ask them slightly differently, it may be different. And so, the reality out there is not the reality of the true score world as considered in survey research. So why do we talk about true scores in survey research? Because it's a useful way to simplify some things when we want to do statistics, when we are in the realm of thinking about statistics appropriately in terms of hypothesis testing and sampling and whatever. When we're living in that realm and we make an assumption that there is a value and we want to measure it, mathematically as an unchanging number on a scale, those assumptions simplify and let us do some interesting things. But they are not a reflection of the real world. So they align to the real world only imperfectly. Um, and so the latent true scores, helpful. We want to do something like reliability assessment, factor analysis, item response theory, change or causal modeling, or things. They're very helpful for that. And those things, have helpful outcomes to help us make decisions, but they do not reflect a deep truth about the world. So they are an approximation, they're useful, but they're not a deep truth of the world. So does this mean that surveys are useless? No, they're motivated communications. This is something that's not new in the human experience. Whenever we do something like a job interview or, whatever it might be, go on a date or, buy a new car, whatever it might be, there's motivated communication, pervasively in the human experience, and surveys are part of that world. And so our job when writing a survey is design ones that answer a business question by engaging respondents, using appropriate survey science methods that try to align respondents' motivations with ours so we can maximize the odds of a useful answer to our business. So let's take, if you buy, my claim that this is what we're doing in surveys, let's look at how that maps to what these LLM synthetic data systems are doing. First of all, the business question is extraneous to the LLM. We bring the business question from our business, so it doesn't know about that. That's why we're engaging in it. Secondly, I claim that what we should do in surveys is to learn from people. That's not what LLMs do. They compute, a statistical reduction of a large set of, linguistic texts. But that's not really learning from people in a specific way for our question. It's pre-computing a kind of data reduction of a vast corpus. They don't do it in real time. The prompts are in real time, but updating the model is not in real time. They do not respond to questionnaire methods and wording the way people do. The motivations of the systems are different than human motivation, so those things don't align. And whether it will maximize the odds of a useful answer to our business, that's not what they're designed to do. LLMs are designed to, reproduce the training data that's given into them in a way that people like the results that come out of it. That a priori does not align necessarily with the useful answer to a business question. If anything, they're more likely to tell you that your idea is great because, that's what people like when LLMs are trained. But that may not be useful. So my conclusion from this is that there's no survey answer that these models can generate for us. And if we say, no, but wait, they do work, then we're back in the situation of section 2, which is to say, statistically, you cannot prove a priori that they work. Okay, so I'm going to return to this random sampling thing that I kind of shelved and said, what was going on with that? So our goal in survey research is to learn from people. It's not to meet a statistical definition of random sampling. That's a helpful simplification. It lets us do some math that, often is useful to do, but it's not a reflection of the real world. And our goal is not to get there. And there's a subtle point where this often comes in discussion of LLMs where they say, yeah, but you get a larger effective sample size. If you take the data and you add the data to what you get from people, you're increasing your power. Well, all of those concepts, effective sample size and power and so forth, those go into these assumptions that what we want to do is to have a random sample and that can be characterized by things like a standard error, and that we want to do hypothesis. We're back, those assumptions come from this world of the statistical inference that does not apply to LLMs. And so to the extent that it, quote, makes a sample larger, for example, or something like that, we're back in this realm of concepts that I think don't apply. And that's not what we need to be worried about. We need to be worrying about learning from people to answer our business question. And then the question for sampling is, have we reached a large enough group of people, diverse enough, maybe with a diverse number of methods, that we feel comfortable about the business decision we're going to answer? And so LLMs don't reach people and they're biased, et cetera, et cetera. So I think they never pass this bar for learning from people. And rather than say, taking a human sample and adding an LLM sample to it in order to have a larger sample, I'd say you'd be much better off doing something like some interviews. Take your survey data that you have, maybe it's a small sample. Now let's use a couple of other methods. Stop thinking about these things of like meeting some power analysis, which is based on statistical concepts that are useful, but should not be taken as a reflection of reality. So, and another implication from this is that a random sample is not necessarily a good sample. We all know that. So we're always using judgment about all of this. So I would say, that we need to design surveys in the face of this motivated communication and viewing statistics as helpful, but not as a definition of truth. And instead of hoping that LLMs can magically take surveys for us, we need to rely on survey science, iterating, learning from people in multiple modes, such as qualitative as well as quantitative research. All right. So I've previewed a couple of these already, but I'm going to consider quickly some rebuttals and what I would say to them, and then we'll have lots of time. Justin has offered, and I'm delighted to do Q&A as long as we want. So I often hear these claims. I'm going to go through them. One is that synthetic data will accelerate research by getting quick answers or more sample. I just talked about the more sample part, but I also say, do you care if the answers are correct? There's no a priori reason to assume that they will be correct for all the reasons I laid out. So yeah, it'll be faster. A claim I sometimes hear, and this is often in the conjoint and MaxDiff world, but sometimes in other kinds of Bayesian worlds, is that we can use the LLMs to get priors for our Bayesian models. And so that by obtaining these priors from the LLM, we now have a starting point in our models, and that lets the models converge better or faster, whatever. We get improved Bayesian results. I believe that confuses information, with math. So again, this will do math. If you feed in priors from your LLMs, that math will go into your model, but I'm not sure that it's good information. And the Bayesian models, again, the underlying concept is that you have information that's going into them that is then represented mathematically. And I'm not sure, for all the reasons laid out, that we have information from them. Another is that you can use these to pretest your survey. I think it's better to pretest a survey using random responses. Why? Because they are going to test every branch of your survey and every possible response in an unbiased way. And so I think pretesting is much better off using just simple random responses, which most survey platforms like Sawtooth have as a possibility. Another is that we can use it to preview potential results for discussion with stakeholders. I think it's better to construct those potential results, to go to my stakeholders and say, what if people love this concept? What if they're indifferent? What if they hate it? I would rather construct the potential outcomes, often based on prior research, and have those scenarios laid out with the stakeholders so that I can, better tune my research to what they would do with them. There's claims that technology always gets better. It doesn't. I think this is somewhat a form of survivorship bias. Most new products, do not last over the long term, including most technology products. I think if we look back at any product we have now, we can see that it got better over time, but that's survivorship. So we don't know where the technology will go. Then we get sort of organizational things that, I'll be left behind or I'm being told I have to use it. And, I, um, you know, those are difficult things, but, those we have to deal with, like any organizational question. So, so to kind of boil it down, I would say synthetic data, there's no theoretical reason it should work. And we should assume that it is presumptively wrong for interesting and especially novel and actionable questions. Um, the empirical results often show vast differences. So aligning with that, sometimes they agree with humans, sometimes they don't. They often show big differences. There's no expectation that it will generalize. And I think, as I've argued, that's because the statistical concepts underlying sampling and comparing data, from different groups do not apply in this case. So they are not sampling from any definable population. And so statistical comparisons are generally invalid. And I believe it relies on this, simplistic concept of pulling a true score out of people's heads, which is not what surveys do. So I believe we should learn from people in real time to answer crucial questions. And that's done best by asking people. So if I put this whole talk in one slide, you've seen this slide already. This path, I think, of doing this, it doesn't generalize to anything. It produces some output, but we don't know whether that output will be useful or not a priori in any case. But this other path of identifying a business question and asking people, that generalizes to people. So I think if our job is to, generalize to people and understand them, we're much better off in this situation. I'm going to point out a couple of references here. So the Morris and Verisight thing that's here on the right, I've put in some others. This left, I will call out, looks at brand perception and whether adding more attributes from digital twins improves results from LLMs. Preview, it did not. But this is great research for those of us working in the branding space. I'll point out to look at left. Samaliev here has a nice blog post that includes R code where you can prompt LLMs, using their APIs with your own problem and prompts, and then gives you how to test the synthetic respondents. And Paxton and Yang here looked at this. These are two Google researchers, looked at LLMs in the sentiment space. I will put a caveat on all of these on the left-hand side here, that these are based on statistical null hypothesis comparison here. And so, you can sort of apply my caveats about that. Then I put a few things from my blog here on the right, which is the quantuxblog.com. But I know Justin will share the slides, so you can find those. That's it. Thank you. I will be happy to take any questions now and also stay as long as people would like. So,
Thank you, Chris. So good. Hold on one second. We're just gonna make a few more announcements here and then get to the Q&A. Hopefully you enjoyed Chris's presentation. I've seen it a few times. He's excellent. And Chris, thank you so much for all the preparation and for the delivery. And I sincerely believe Chris is just trying to do the right thing here. He's trying I mean, it's definitely his opinion, but yeah, it's very good and a lot of great points. We appreciate it. Okay, so next month, March 18th through 20th, we have a workshop out in San Francisco, MaxDiff and conjoint analysis. You can actually get a newly developed MaxDiff Sawtooth certification if you attend that workshop. March 26th, we have Pricing Research Tools You Must Know by Brian Orm, next webinar coming up. And then this big Sawtooth Research Conference. We think it's great. We think you should come. May 6th through 8th out in Berlin. And then, as Chris mentioned, he has an incredible Quant UX Con. It's all virtual. It's low to no cost for some folks, and you can check it out at quantuxcon.org. And then again, for the Sawtooth events, see sawtooth.com/events. And just a reminder here, you can hear other presentations with different opinions about synthetic data coming up in Berlin at the SRC conference. And including on June 18th, we're going to do another Sawtooth webinar Can synthetic respondents replace the real thing? You might want to tune in for that. Early bird registration, March 2nd. And if you can't make it to Berlin, we do have virtual options. And then again, check us out, discover.sawtooth.com for a great tool to do your research. With that, Chris, we do have tons of questions. And again, Chris is graciously going to stay a little later. If you have to leave, that's fine. We will send you this recording and the slides. Chris is going to share his slides and the recording that will go to everybody who registered. And with that, Chris, I'm going to help you with these questions.
Right. You can
Um,
identify them, or I can just run through the list. Either way, it's a wonderful
yeah,
I think
lesson.
we can probably cut out quite a lot of them, Chris, by getting your views on the difference between what you've talked about today with LLM generated responses and what is also been termed synthetic data with model generated responses, and whether you feel a lot of your critique of LLMs also cover some of these other methods.
Yeah. Well, I'm seeing one question here from Mohammed. Some said, recent research shows that combining data, of humans plus LLMs outperforms either one alone. And there are a number of studies like this. And I think this gets to, my point that those are all predicated on the idea that what we want to do is to recreate some true score and to have statistical power. And we're in that universe after we accept, that we've met the criteria of doing statistical comparison in the first place. And I don't think these models meet that criterion. And so, kind of that entire domain of things seems a bit off the mark to me, which is like, maybe by adding AI, we've gone from an effective sample of 300 and expect, an effective sample of 1,000. But I'm like, but the number of the sample is not the key thing. The question is, do we have good data that we're prompting people in the right way to begin with? And effective sample size is a useful concept, for other things. So I think a lot of those things about kind of hybrid go down that path. And that's kind of my fundamental problem, I think, with any of these model generated sorts of answers is, we don't know what they generalize to.
Chris,
Um,
I would like to see if we can answer everybody's question. If you just want to like
yeah,
read the question at the top and then answer it, and then I'll go ahead and close them down as
sounds
you answer.
good. Yeah, okay. So Dylan asked, is it taking a sample from a population, scrambling and recombining it? Sort of. I would say it's taking, linguistic texts from the internet, setting aside images and that sort of thing. And then it's modeling those texts so it can, recreate them with some sort of lossy, kind of data compression scheme. That's what it's doing with the weights. And then we're prompting that. And so it's, recapitulating in some remixed way these linguistic things. Yeah, that's what they're doing. I don't think that tells us much about, what's going on inside humans' heads as motivated responses to our business questions. So, okay. Arav, it's great to hear from you, Arav. Yeah, I think I got to the sampling question, later on, which is the question of, you know, do we believe we've done research effectively using appropriate methods and reaching appropriate people to answer a question? And so I, don't worry a lot about the question of random sampling, but whether, the sampling is good enough. And, there are tools, I think, to the extent we can make it match a user population or a census or, some other sort of target representation of users that we have, we're better off doing that. It's not to say we shouldn't do that, but I just see that as one tool to try to make sure that we're, really reaching the people that we need to learn from. Okay, I'm gonna go. Let's see. Yeah, the Yeah, the question Ellen asked, these examples are showing attitudes and behaviors, and are those also, equally different for things like brand? I would say go look at the left study that I have in the appendix there, and they look specifically at brand. And so I think the overall view is, I think, quite similar, which is to say sometimes they agree, sometimes they don't, and we don't know in advance whether they will or not. Doug has asked, what do I think about the predictiveness or not of traditional survey metrics such as purchase intent, and how representative are surveys really these days? To question number two, there is a kind of arms race for sure about panel participation and fraud and bad actors and all that. And I think we have to do a few things there. One is try to make our panels as good as we can. I think another thing we have to do is to consider alternative data sources besides panels. And one that I, increasingly, have done in my career is to, blend in-person research, with online research and look at the differences. And, if I get people in a room, then I know who they are, and I know that. So I think, a lot of this is bringing back the importance of qualitative research. As to the predictiveness of purchase intent and that sort of thing, that's a long discussion, and I will kind of defer that to the conjoint analysis world. But my short answer there is, I think when we learn about a space well and iterate and use methods like a conjoint analysis, we can do really, really well in a mature market, especially to predict those things. But it really depends on bringing in traditional survey science kind of expertise and iterating. Okay, Elizabeth asked, do I think advancing models will normalize the differences I noted? I think, we don't know. I think it's back in this realm of, these things are representing some vast space that has no known structure or enumerability. And so the statistical concepts still won't apply to it. And, if someone says, well, what if an AI really could give us, what if you did 1,000 surveys, and for 1,000 surveys in a row, it gave you the exact right answer every time? I would say, well, when we're in that world, let's talk about it again. There's some classic, philosophical texts about, causality, and how do you know if the sun comes up every day that it will come up again tomorrow? And we would be in that kind of theoretical world. But, that's a hypothetical that I'd say, until we're there, I wouldn't assume that we will get there. Okay, let's see. Dima asks, yeah, this is a tough one, and I don't have to think about this one a lot, which is that what do you say to clients, who want to use synthetic data, and how do you argue that it should not be used? Which point is most salient? I think that depends on the client, but I think what I increasingly did, and this is it's hard to sell this. I won't say it's easy to sell it. Which is to blend in-person research, and there's so many advantages to that. And if you want to look at something like effective sample size, I've done some work on this. You can find a poster I gave some years ago, which shows at the time that doing conjoint analysis in person with people had effectively 10x of the effective sample as doing it with online. Why? Because people in person take the task more seriously and all this. Yes, you'll get larger, quote, standard errors and things in the statistics world, but directionally, the answers are just as good and useful as a much larger sample done through a typical panel platform. And I think that's, as the panel platform quality has degraded over the years, that's become even more the case, that the in-person research will give you more and more and more. So then the question is, as I see it, is how to kind of sell these combined research approaches to stakeholders. And my take on that's they're hard to sell up front. to stakeholders. In-person research appears to cost much more than online research. But I think after they see it and see, how compelling it is to get, results from an online survey panel combined with, qualitative results and nice verbatims and video clips and all the kind of drama that you get from qualitative research. I think once they see that combined package, it's extremely salient. And luckily, compared to panel responses, the difference between in-person and panels is decreasing because you need more people from the panels and you have to pay for them. And so it's becoming somewhat easier to show the cost effectiveness, I think, of in-person research, in conjunction with paid panels. If you're in the space of, well, I can get it from an LLM for free, then that's a very difficult space. So I empathize with you. Okay. Yeah, Alex says LLMs thought of as a Monte Carlo simulation, but you don't understand the parameters. Yeah, that's one way to look at it. I mean, these models have billions or now even trillions of parameters, and and you're using those parameters to do some sort of covariate, which is trained to recreate the linguistic text, not to recreate any survey data unless they've seen survey results previously as part of their corpus. So yeah, that's one way to think of it. Samantha. Is there any way to derive synthetic data that would be good enough? For example, people are doing imputation with things like random forest. Yeah, the kind of data imputation and using traditional statistical methods like random forest or other kind of maximum likelihood inferential statistics, and it's great work in that space done by Gary King, for example, and some colleagues at the Harvard Quantitative Social Science Institute. That I would call out specifically. I don't have anything to say about those approaches. I generally like them and sometimes use them if the questions of, when and how much imputation you should do. Imputation from LLMs, I think the concern I have there is, twofold. One is this question of, are we already, in the world of trying to optimize for statistical concepts that are not really the point. That was part 3 of my talk. But I think the second problem I have is, unlike something like a random forest imputation, we don't really know what the models are doing. They're not transparent, and we don't have a good way to test them. There's no way to assess the reliability in that. So I think we're back in this domain of a priori, we don't know whether they'll be good enough even from a theoretical perspective. Okay, Angela, it's great. I don't know if you're still here. Thank you for the question. Yeah, what would I say when a vendor says that they've trained it on previous responses? I would say, first of all, if you have data to the responses that you're asking about, just use that data. You don't need to put the data through some data reduction algorithm of an LLM and then try to recreate it by prompting it. So if they have data on the question that you're asking, then use the data on the question you're asking. That's going to be better than some approximation of it. Yeah, and then I think, when we're in this camp, this was kind of part 2, when I said when suppliers do a study and they say, oh, we can prove using this that we've done these tests and our model's working. I will point out, when you get the slides from Justin, I have in the appendix, I have questions to ask about supplier studies and vendor studies. And, a couple of them that come to mind, when they're training models on these, one is there a file door problem? Are they only showing the success cases? So they're always, of course, going to show you a curated set of studies they've done. How many other studies did they do that you don't know the results of and they're not showing you? So I worry about that. And that gets to the question of pre-registered research and, kind of open research practices. And those are almost never done. in industry. So that's one question. And then I think the other question is, how do we know whether the results, in fact, in their model, may have been targeted to, like they've designed a model to answer some specific set of things, and then they're testing to that, and you don't know how well it's doing. And in my blog, I linked to an example that's not in the survey world, but it was an article about these AI models scoring very highly on IQ tests. And you can give them the questions from an IQ test and they will score highly on the answers from the IQ test, probably because they have seen the answers from the IQ test as part of their training data. And so we can't conclude much of anything about it. And so I worry about that and the degree to which they're testing to the training conditions or training to the test conditions. Okay. Do I see room or value for using LLMs to pilot? This is Ellen and explore and run confirmatory tests. Honestly, I would pilot with people. I believe our job is to learn from people. And so if someone tells me, they used an LLM and it found some bugs and in their survey logic or whatever, then I'm in the camp of asking myself, whether those benefits, are worth, some of the other concerns, like that stakeholders who hear that may then conclude LLMs can give you the answers or something. So I would start to think about, I think, a kind of risk benefit analysis there, but I always pilot with people. Yeah, Casey, can we wait and get more? Yeah, I think I've already answered that one. Waiting, which is that, I think it's synthetic data. Matt, synthetic data for imputation. I've answered that one, I think. Shruti asks, we built synthetic data segments and then trained it using qual data. Yeah, I think I'd need to know more about what's going on there, but I will just say that I don't really have a response other than to say I love the combination of quant and qual in general, and I think that's better than trying to just optimize on the quant side alone. Yeah, Jose, I think same thing, kind of synthetic imputation I've already answered. Mani's asking, I'm sure synthetic data is not reliable, so it differs from humans. What can I say about the validity in startups selling qualitative research at scale? Yeah, the question of the validity of, AI data rarely comes up, and I think it's something that we really need to ask ourselves, specifically. And again, to point to my blog post about the IQ test as one example, I talk a lot about the validity there, which is that IQ tests, for example, are designed to assess, problematically or not, and there are some problems, so I'll stipulate to that. But if we kind of, accept, the world of such testing to begin with, then they are designed to assess the differences in human performance, across people on specific tasks that are tasks of human cognition that map to a particular set of concepts and constructs in cognition. So similarly, our surveys, are designed to assess people's behaviors, like their liking of our product and their likelihood to purchase it, based on concepts that we have that are appropriate for human cognition. And the appropriateness of those concepts and assessing the diversity of humans does not apply to LLMs. And my talk goes into that in the IQ space, but I think it applies in the survey space. And we almost never talk about that validity question. So, I appreciate you raising it. Okay, let's see. David asks, And I'm not sure if this is David that I know from long ago. If so, welcome. It's great to see you, David, if you're still here. Suppose in the future LLMs trained on a huge number of survey responses on a common type. Yeah, I think I've already, I think I'd have the same response, which is that if you have the data, just use the data. And there's some limit where we could think about, an LLM perfectly reproduces an exact text and can give you back the exact answers to data. And so the vendor's not going to give you the data, but they'll give you back an exact replica of the data if you pay them to prompt their. I'd say if you have the data, use it. If we're in the world where, we show many, many, many times that it's recapitulating data, then, I think we reconsider some of these when we get there. So in principle, I don't really have a problem, but I think we're far away from that world. And I see that Dean has a hand up. So
Yeah, I'd just like to add to that. So, like NPS surveys and customer surveys are supposed to be leading indicators of problems that are about to happen in the future. So using synthetic data for those kind of studies just doesn't seem like it's the right use of it in my mind.
Oh, that's great. And that gets to my in my talk, the point that, our job is to kind of learn from people in real time. And so yeah, I completely agree. Thank you, Dean. Yeah.
How you doing, Chris? 15 minutes after we still
Yeah,
got
I'm doing great.
still got 32 questions.
I see folks still here. I'll keep going, maybe till the bottom of the hour, 15 more minutes. And I'm sort of, okay. Jeanette asked, can I expand on why LLMs are biased? I would just point to the literature on that, and I'd say, one of the folks who's done a lot of work in that space is Emily Bender, who's local here at the University of Washington in Seattle, and co-author Alex Hanna. And and the biases come from many sources. They come from the data that go into it, which overrepresent Western, highly educated, online, kinds of data sources. They go through how the training's done. It goes through how the models are optimized, to meet the business goals of the model providers. So bias can come in a number of different forms. But I'd point you to, I think, those results. Matt, synthetic data for imputation, I think I've answered that. Dylan asked, the speculated overlap between AI leaders and the eugenics movement. How are people with disabilities affected by LLM synthetic data? Yeah, I will stay out of the political realm, I think, in answering here, but I will say that, I do worry about the representation of folks in the training data. And so I often see claims that LLMs will provide greater representation of a holistic space of folks and provide greater inclusion of people with disabilities, or who are otherwise underrepresented. Um, and I would just say, go and see what those communities have to say about that. So I would defer to those communities and listen to what they have to say about inclusion and representation, rather than the claims of the sellers of the system. So there are a lot of claims in that space, but I would go and listen to, I think, the people who are actually in those communities. Craig asks. Hi, Craig. It seems there was a big focus on wrapper-based models or custom foundational models trained. Yeah, so these are kind of generic LLMs are mostly what I talked about. Do you believe that if we have some sort of more customization, that it helps mitigate some of the points? I think the answer is, in principle, yes. It gets back to the validity question of, if we are more specifically, designing for and targeting the constructs of interest, that should help. And then we're in the camp of, how do we evaluate that? And so it brings up some of the concerns I had about statistics and showing that. So I think yes, in principle, a more focused model should be better than a generic model in some domain. And that often comes about in the training process of how the training is occurring and um, what the goal of the training process for the LLM is. Um, then the question of whether can we believe it a priori and in advance, and will it work for our problem? Those questions remain. They just become, I think, a smaller set of them. So I hope that helps. Yeah, TRS, I said LLMs do not answer the surveys the same way as people. Is it based on prior survey results? Without going too much into how LLMs work here, and again, it varies somewhat from model to model and this sort of thing. Basically, what they do is when you prompt them with your survey question and answers and the data and all this, I will refer to a piece by Stephen Wolfram of Mathematica fame, who wrote something called like How Do LLMs Work. I forget the exact title. You can find it via Wolfram, WLFRAM, and LLM Explainer. He's got a really nice blog piece. And basically, they take, the question you put in and it gets mapped to the same statistical weights. So they're now weighting all the things you go in. It gets decomposed in those training weights. And then they're looking at, kind of similarity in this trillion dimensional space between the question you asked and its training things. And then that, starts to go into the generative output model where it, goes through various layers to create a plausible kind of linguistically structured output that's grammatical and all that, to align with your answer. So if they have prior survey results in this vast corpus, those would be included, and presumably they'd be overweighted because it's mapping to these weights. But in principle, it's using the entire space of all these things that they've sucked up from the internet and training. And that's one reason we don't know when it will work and when it won't. Okay. What will it take for synthetic data to work? I think it depends on the question we're asking. So I think these questions of will it recreate human data, I think, is along the lines in part of what Dean mentioned, that our job is to learn what's happening in real time and recreate that. I think it never can. And are there other use cases for it besides going down this path of recreating survey results? That's a different talk. So I think I would defer on that. Julianne, negative sentiment being underrepresented with LLMs. Do I see LLMs improving? Where are they best used? Okay, so the third one, where are they best used, I'll defer on that because I'm limiting myself just to the survey space. And the point about negative sentiment, I didn't really mean to say that negative sentiment is underrepresented with LLMs, although they are trained to give back. One of the training things that's often used, and this has been criticized with them, is to give back responses that people like. So they tend to tell you things that you like to hear, and you can find folks who've shown, I asked about my business idea and it told me it's the greatest business idea ever. And so, so they definitely have some kind of positive acquiescence bias in general, but that's not specific to survey responses. The specific point that I showed about negative sentiment was that those were the points where they, in the Morris and Verisight study, where it was off by the largest degree. I suspect, but I can't prove, that that's because they are either. I suspect that's because the training data and process just are not a good representation of the distribution of people's sentiment on any specific thing. In particular, in the political realm, which that study was about, we know that online sentiment is vastly more polarized than general sentiment, offline sentiment in the political realm. And so I think we can expect a priori that things trained from an online data source are going to be more polarized in something like the political realm. And that's what they had empirically, but so I think that's all I would say there. How do I really those say the LLM tries a lot overly simplistic? Yeah. So this is the thing that often comes up is well, we tried it and we got great results. And our model is a vast improvement. Don't use a generic model. Use our model, which has been custom tuned. And I would refer you to the slide that I have in the appendix, which asks questions. And one of the questions that I would have there is, will they do a pre-registered trial for you? And the way this would have to work, you would have to have the pre-registration of the answer in advance of anyone prompting their model with your question. And so it might work, for example, let's sit down and I'm going to give you a question and I want you to tell me the level of accuracy your model is going to have, but you can't prompt your model with the question. To know. I want you to tell me on first principles, what you believe the accuracy will be. And this is something in a known domain like, the political context that pollsters will often have. They'll say, we believe we can poll, within plus or minus 10 points or something like that. And so they can give you a pre-registered level of accuracy that you expect. And then you go and see whether they deliver that. And so I would ask a vendor, will they give you a pre-registered level of accuracy? And then you do the test. And then you can evaluate, well, that was an N of one case. So how much, do I believe that will work for my problem, for the next problem? But I would say that's, rather than just accepting their claims that the model somehow better, I would want to test it. Still have the problems of, it's not a sample and all that I talked about, but that's in principle the path I go down. Abe asks, have I successfully made these arguments to non-statistically minded audiences? Yeah, I mean, I agree with you, Abe. I think, this is a very conceptual talk that I gave here. And, my goal is to kind of, try to shore up some of the fundamental concepts or misconceptions here. And yeah, that won't land with other audiences. I've not had to deal with many of these audiences, mostly by proxy, in my new role where people come and ask me about it. I think the things that I would, do here, one which I already talked about earlier, is try to, show the value of having a larger conception of research, that it's not about getting an answer, but it's about understanding people. And when stakeholders kind of, can see that the value of, qualitative and broader things, that often opens their mind. Another argument, which I, am not going into here, but I've seen folks make it, is to make the arguments on different grounds, like, ethical grounds or, taking into account other things. So that's a path I think people go down. This is risky, but to do a live trial and just sort of demonstrate, and, you're kind of flipping a coin there. So you have to think about how to flip a coin and think about that. But I often do kind of live statistical demonstrations with folks. There's really nice book by Andy Gelman, The Bayesian Stats, called Teaching Statistics, a Bag of Tricks, something like that. He's got some kind of classroom exercises that are really nice. And it gets, much of the book's very technical, but some really nice things that, can kind of demonstrate these things. So that's another approach. Yeah. Anonymous attendee looks like the same question, so I'll skip that one. And I think we are at time now, so it looks like it's the bottom of the hour, 10:29. I would say a huge thank you to everyone for these questions. I hope this is helpful here, and you can follow up with me, the quantuxblog.com or quantuxa.org. Thank you all for attending.
Thanks so much, Chris. We really appreciate all your time.